Welcome to this video on map reading and navigation. This session will cover the fundamentals of understanding and using maps effectively for navigation. The video overview includes the types of maps used within the SES, how to use various maps covering scale, grid references, and ground shape. We will also discuss compasses, bearings, cross-country navigation, and remote area preparedness. The main aim of map reading is to navigate, recognize features, and visualize the ground even if it hasn't been seen. It also helps to understand and communicate information quickly and determine a safe route. A map is a scaled representation of the Earth's surface on a plan. It shows both natural and artificial features and conveys land information. Remember, a map is only accurate at the time of its aerial photo or field revision. We use different types of maps, including street directories, topographic maps, thematic maps, scientific maps, and mud maps. Each type serves a specific purpose in navigation and spatial understanding. A street directory contains several key components, such as the addition, a key map, a suburb index, a facility index, a street index, and map references. These elements help locate places efficiently. Topographic maps provide detailed information about natural and man-made features, including elevation and terrain contours. They are essential for navigation in remote or unfamiliar areas. Map care is important to prevent deterioration from dirt or grime. Always protect your map with a case, clear contact, or plastic bag. When folding, fold in half with detail facing outward, concertina into equal sections, and finally fold in half with the title showing. Marginal information is printed around the map's margin to aid its use. This includes the title, scale, type, legend of symbols, edition, sheet number, adjoining maps, contour interval, magnetic variation, and the grid reference block. Conventional symbols represent features on the map. These include water features, structures, boundaries, road and rail networks, and various land features. Understanding these symbols is crucial for map interpretation. All mapping and coordinate systems are based on a datum, a mathematical surface that best fits the Earth's shape. Key datums include AGD 66, AGD 84, GDA 94, and WGS 84, which is used for satellite navigation. GDA 94 and WGS 84 are practically the same. Scale is expressed in three ways: in words, as a representative fraction, and using a linear scale. A helpful trick for representative fraction like 1 to 25,000 is to remove the last two zeros to get the actual size on the ground in meters. To measure straight line distance on a map, you can use paper, a divider, or a ruler. For measuring distance along a road or track, which is often curved, use curved paper or a length of string. Map coordinates come in two types: geographical, using latitude and longitude, and grid coordinates, using eastings and northings. Latitude and longitude use degrees, minutes, and seconds, with each degree and minute divided into 60 graduations. Grid coordinates are used to precisely locate objects. They consist of two sets of numbered parallel lines that form squares, typically 1 kilometer squared. The vertical lines are eastings, and the horizontal lines are northings. Eastings are the vertical lines, numbered left to right, and northings are the horizontal lines, numbered bottom to top. Always read the eastings first, then the northings. Remember the tip: across first, then up, or E before N. Four-figure area references represent a whole square, not a single point. For example, 1201 represents a 1 square kilometer area. To locate it, find the 12 easting first, then the 01 northing second. A 6-figure reference is 1/100th the size of a 4-figure reference, representing a 100 square meter area, such as 122016. For 8-figure grid references, roamers can be used to further refine the location, down to 10 square meters. The Global Positioning System, or GPS, is a satellite-based navigation tool developed by the U.S. Defense System. It uses 24 satellites orbiting Earth twice a day. GPS provides your position, height, speed, and direction of travel using the WGS 84 datum. GPS signals use the triangulation principle, but do not penetrate buildings or thick scrub easily. A minimum of 4 satellites are needed for accurate 3D position, and the typical accuracy is within 30 meters 95% of the time. Universal grid references are also known as Universal Transverse Mercator, or UTM. A grid system is superimposed over the world map, with each square uniquely identified, such as 56H. This is further bisected until the squares are down to 100 square meters. Ground shape is referred to as relief and allows the user to visualize the surroundings. Relief can be shown on maps using hachures, hill shading, or contours. A contour is a line that joins points of equal elevation. The contour interval is the vertical distance between contour lines. This interval can be found in the map legend. Contour lines close together indicate steep slopes, while lines far apart show gentle slopes. Evenly spaced lines mean a uniform slope. Spacing changes can indicate convex or concave slopes. Land features such as knolls, saddles, spurs, valleys, and plateaus are represented on maps. These features can also show height representation using benchmarks, trig stations, and spot heights. Gradient is a method of expressing ground slope. It is calculated by dividing the contour interval by the horizontal distance. The result is simplified to the smallest fraction, like 1 to 6, meaning 1 unit up for every 6 units across. Intervisibility, or line of sight, is important for determining the location of communication points, such as radio repeaters and fire lookout towers. Map enlarging creates a portion of the map at a larger scale. This technique is useful for detailed focus on a specific area, and more information can be found in the learner's guide. The compass uses the degree system, a 360-degree circle where north is 0 or 360 degrees. Other points include south at 180 degrees, east at 90 degrees, and west at 270 degrees. While there are 32 cardinal points, only 16 are typically used. A bearing is an angle measured clockwise from a fixed north line to give an accurate direction from one point to another. Grid bearings are used when referencing a map, while magnetic bearings are for field operations using a compass. Bearings are measured using a protractor or a compass. There are 3 types of north: true north, magnetic north, and grid north. True north is the Earth's rotational axis. Magnetic north is where a compass needle points, which is a location in far northern Canada. Grid north is the vertical lines on a map. Magnetic variation is the difference between grid north and magnetic north. Remember that the magnetic north pole is constantly moving. Always check the map for the accuracy of the magnetic variation, as it can be easterly or westerly. Bearings must be converted between magnetic and grid for plotting or compass work. To convert, simply add or subtract the variation. Use the acronyms GMS for grid to magnetic, subtract, and MGA for magnetic to grid, add. Grid bearings are always larger than magnetic bearings with an easterly variation. A back bearing is the opposite direction of the current bearing. To calculate it, add 180 degrees if the bearing is smaller than 180 degrees, or subtract 180 degrees if it is larger. You can also reverse your compass to find the back bearing. Compasses come in many types, including prismatic, reflective, and silva. They consist of a magnetized needle, a non-ferrous or plastic box, a graduated 360-degree circle, and sometimes an aiming point. Pictured here are the silva compass and the prismatic compass, 2 common types used for navigation. To take a grid bearing, place the compass edge along the intended line on the map, pointing the direction arrow toward travel. Rotate the housing until the meridian lines are parallel to the eastings. Read the grid bearing. This must be converted to a magnetic bearing for field use. To set a magnetic bearing, hold the compass flat, rotate the housing to the desired bearing, and turn yourself until the red needle aligns with north. To take a magnetic bearing, point the directional arrow at the object, then rotate the housing until the north aligns with the red arrow. Compass errors can arise from individual compass variations or local magnetic attractions from metal objects like transmission lines, cars, or wire fences. For compass back bearings, simply face the opposite direction, or use the white needle as the directional indicator. Cross-country navigation is influenced by factors like weather, terrain, and team fatigue. Improvised direction finding can be done using the shadow stick and sun, the stars, a watch and sun, or even a GPS. Predicted walking time varies based on terrain, from 5 kilometers per hour for easy walking to 1.5 kilometers per hour for rough country. Allow extra time for elevation changes and fatigue. Distance can be measured by pacing, with approximately 650 to 660 right steps equaling 1 kilometer. Route planning is essential and requires careful map study. Break the route into individual legs, ideally terminating at recognizable objects or within an hour's travel. Always consider the terrain, including ridges, rivers, scrub, and access restrictions. Map orientation can be done using land features or a compass. To use a compass, set the magnetic variation, align the compass edge with the north-south meridian lines, and rotate the map and compass until the needle aligns. Lateral drift is when you stray from the intended destination while staying on the same bearing. To eliminate drift, spot a feature on the set bearing. Walk to it, reassess, and repeat until the destination is reached. To avoid an obstacle, use pacing at 90-degree intervals. The first and third legs of your traverse must be of equal distance to return to your original line of travel after navigating around the obstruction.